Okay, I'm going to help you with set 4 questions. As always, I would like for you to have a go at doing the question, then listen and watch my explanation to check it, but I want you to have a go at yours first. If you're completely stuck, feel free to watch my first question, then go ahead and do the next one all by yourself. Just pause the video, have a go at it by yourself, okay? Because the goal is that you can do these by yourself. I'm just here to help you. All right, so question 1 says that we're rolling a die. So a die is rolled. Complete the following to determine whether the events A and B are mutually exclusive or non-mutually exclusive. I'm going to write you a little note here about what each of these things mean. So mutually exclusive means that only one thing can occur. We can't be doubling up. The same thing doesn't fit both categories. Okay? So mutually exclusive means that the two things can't both occur at the same time. For example, I can't be both playing football and sitting in a classroom at school at the same time. They're two completely different things. I can't be doing both of them at once. Whereas a non-mutually exclusive event means that they can both occur at the same time. So if I was to draw a card from a deck of cards, it could be both an even number and a red card because there are cards that fit both those criteria. Okay, so a red card that was 2, 4, 6, or 8, or even 10, could fit both the categories of their even numbers, and they could also both be red cards in my deck of cards. Okay, so non-mutually exclusive can fit into multiple categories. I'm just going to write into 2 categories for now because that's what we're looking at. So non-mutually exclusive events can fit into 2 categories at once. Okay, like my cards that can be both even numbers and red cards. Mutually exclusive events are one or the other, okay? Cannot be both. So I need you to keep that in mind. Cannot be both. Okay, I need you to keep that in mind while we do these questions. So A is the event of a 5 happening. The sample space of A is, well, it's just 5. In this event, the only thing that can happen is 5. So the sample space of A is going to be 5. All right, B is the event that 6 happens. So what's the sample space? Well, the sample space is everything that can happen, and in this case, it's just a 6. Okay, look at these 2 things we've just written. We've got 5 and we've got 6. Now, do you see the same number occur in both of those? No, you don't. Okay, so we can't fit into both categories. We can't both be a 5 and a 6. So we cannot be both. So we're in the mutually exclusive category here. All right, the next one says A is the event of a 5 happening. So the sample space again of A is 5 because that's what's happening. B is the event of an odd number. The sample space of B is. Now, I don't know where my odd numbers go to. Actually, yes, I do because we're rolling a die. So we're going up to the number 6. So we've got 1, we've got 3, and we've got 5. They're all the odd numbers on my die. Okay, so that's my sample space. So 1, 3, and 5 is my sample space. Now have a look at these 2 sets, A and B. Is there a common number in both of them? Is it possible to fit into both categories? Is it possible to both be a 5 and be an odd number? And the answer is yes, because there's a 5 in both. So therefore, we are non-mutually exclusive because we can be in both categories. Okay. A is the event an even number happens. So an even number, the sample space of that means that we're looking at 2, 4, and 6. Okay. B is the event of an odd number. The sample space of odd numbers means we're going to go with 1, 3, and 5. Now have a look at my 2 sets, 2, 4, 6, 1, 3, 5. Is it possible to fit into both categories here? No, it's not. It's not possible to both be an even number and an odd number. Okay, it's one or the other. So we're looking at mutually exclusive because you cannot be both. All right, D is the event. A is the event of a multiple of 3. So again, we're looking at our die, all the numbers that are a multiple of 3. So that's going to be 3 and 6 because they're both multiples of 3. They are both divisible by 3. Okay. And B is the event of an even number. So on my die, what are the even numbers? You've got 2, you've got 4, and 6. So here's my question. Is it possible to fit into both categories here? Can you both be a multiple of 3 and an even number? And because we've got the number 6 here, I would say yes, you can. Okay? So we're non-mutually exclusive. It's not just one or the other, but you can actually fall into both categories. Because if you're the number 6, you're both a multiple of 3 and an even number. Okay, question 2. A pair of dice are rolled at the same time. State whether the following events are mutually exclusive or non-mutually exclusive. Okay, so this time we're rolling 2 dice. Okay, so we've got the numbers 1 to 6 on both. We're just looking at normal standard dice. 1, 2, 3. And I might put 4, 5, and 6 on my other one, just so we can see all the numbers. 1, 2, 3, 4. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. Okay, so we've got 2 dice here. Getting a total of 6 and getting a double. So the question is it possible to get a 6 and a double at the same time? So does the number 6 fall into the category of being a double? Well, I could roll a double 3. I could roll a 3 on one die and a 3 on the other. That would give me a double, so I've ticked the double category, and it would also give me the number 6 because I'm adding together 3 and 3, and that makes 6. So is it possible to get both? It is possible to get both, which means that we are non-mutually exclusive. Okay, getting a total of 9 and getting a double. Is it possible to get a 9 and getting a double? How would you get a 9? Well, you could roll a 4 and a 5. You could roll a 6 and a 3. Okay. Are either of those options doubles? They're not. Okay, because 9's not an even number, we can't get a double and a 9 at the same time. So it's not possible to get both a 9 and a double. So these ones are mutually exclusive. Okay, question number 3. A normal 6-sided die is thrown. Match each statement in the left-hand column with its equivalent in the right hand. I would like for you to, again, stop the video, go ahead, have a go at doing it for yourself, and then you can check with me as I do it. Okay, so throwing a 4, 5, or 6. Now we need to find one that matches this in the second column. Throwing a 4, 5, or 6. Throwing at least a 3. Well, no, because that's going to include the number 3. Throwing at most a 5. No. Throwing at most a 4. No. Throwing at least 4. So throwing at least 4 is the same as throwing 4, 5, or 6. So I'm going to match these two together. Okay. Throwing a 1, 2, 3, or 4. Now, that could be described as throwing at most a 4. So it's going to link up with this one. A 1, 2, 3, or 4 is the same as at most throwing a 4. Alright, throwing a 3, 4, 5, or 6. Now that's at least a 3. So it's going to go with my at least a 3 one. And that leaves me with one more. Throwing a 1, 2, 3, 4, or 5 is throwing at most throwing a 5. Question 4. Can you go ahead and have a go at this by yourself, please? And then you can watch the video. The numbers are 0 to 9. The numbers 0 to 9 are written on cards. So we've got cards, and they have the numbers 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 on them. Okay, so there's 10 cards. They've all got a digit on them. Each digit's different. The numbers 0 to 9. Alright. A card is selected at random. List the outcomes for the event that the number is on the card. So at most a 4. If I was to select at most a 4, which numbers does that mean that I could choose? Well, it means I could choose any of these numbers up to 4. So I could choose 0, 1, 2, 3, and 4. At least a 7. If I was to choose a card that was at least 7, that would mean that I'd have to choose a 7, 8, or 9. Okay, at least a 5. If I wanted to choose at least a 5, I could choose a 5, 6, 7, 8, or 9. And at most a 2, well, that means that I couldn't choose any more than a 2. So we're just looking at 0, 1, and 2. The numbers 0 through to 8 are written on cards. So we've got 0, 1, 2, 3, 4, 5, 6, 7, and 8, and they're all written on cards. All right, I'm going to choose a card at random, list the outcomes for the event that the number on the card is at most a 3. So at most a 3 means I can choose any number up to 3. So we're looking at 0, 1, 2, or 3. A number greater than 7. Well, that's going to be greater than 7. Now, it doesn't say 7, so greater than 7. That only leaves me with one possible number to draw, and that's the number 8. At least a 5 means I can choose a 5 or anything bigger than it because it's got to be at least the number 5. So I can go 5, 6, 7, or 8. All right, question 6. I've got 2 coins and they're going to be tossed. So the sample space is listed here. Now I'll explain what this means here. I've got 2 coins, heads and tails. I'm going to flip them both. So my options are, I could either flip a head and then a tails. So head, tails. Or I could flip a head first and then I could flip another head. So heads and heads. Or I could flip a tails and then a heads. So tails, heads. Or I could flip a tails and then another tails. So they're all the possible outcomes. That's my sample space. All right, this is my sample space. There's 4 different things that could happen, and they're listed just here. Okay, so when 2 coins are tossed, the sample space is heads, 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 tails, tails, heads, or tails, tails. That's just everything that could possibly happen, as I've just shown you here. List the outcomes for each event. Okay, so we're looking at these 4 scenarios. 1, 2, 3, 4. All right, so at least one tail. Which one of these has at least one tail? Well, this one does. Heads, heads does not. That one does, and that one does. So these are my 3 options here. So if I wanted at least one tails, that means I could flip heads, tails, tails, heads, or tails, tails. At most one tail. So that means that I can't have any more than one tail. So that is going to mean that I can have no more than one tail. So this one's fine. No more than one tail. That one is also fine because there's no tails at all. No more than one tail. That one is fine, but this one, last one is out. So I've got heads, tails, heads, heads, and tails, heads. All right. C says at least one head. At least one head means I can have head, tails. That's at least one head. Heads, heads is at least one head. Tails, heads is at least one head, but I can't have the last one. So head, tails, head, heads, tails, heads. And at most one heads. Now this means I can't have any more than one head. So I can have no heads or one heads, but I can't have 2 heads. So I can have heads, tails, can't have heads, heads, but I can have tails, heads, and I can have tails, tails. Okay, question 7. A die is rolled. A is the event of an odd number. So odd numbers on my die is going to be 1, 3, and 5. So A is the event I roll a 1, 3, or 5. B is the event of an even number. So B is the event that I roll a 2, 4, and 6 because they're my even numbers. C is the event that I roll a number less than 3. So what are the numbers less than 3? Well, that's just going to be 1 and 2. They're the numbers less than 3. Okay, so list the outcomes for these events. A and B. Well, there's actually not any events, any outcomes that fit into both A and B. If you have a look at A and B, A is all the odd numbers, B is all the even numbers. There's no outcomes that fit into both of those categories. B says A or B. So this time we can have anything in the A category or anything in the B category, which is actually all of the numbers, 1 to 6. What fits into B and C? Well, B and C, you're looking at the number 2. It's in both of those categories. And B or C can be anything in B or anything in C. So we can have 1, 2, 4, or 6.